Hello, my name is Eric Johnson. I'm with the Experimental Nuclear Group at Florida State University. Today I'm going to talk to you a little bit about what I do and as a grad student, what you can kind of do if you wanted to become a grad student or an undergraduate student with the Department of Physics. So first I'm just going to tell you a little bit about our nuclear physics lab that is actually on campus here at Florida State. And I think it's one of the best labs for students in the country because you get hands-on experience from the very beginning of an experiment all the way to the end of the experiment. What I mean by that is in a nuclear physics experiment, you first have to produce the beam of nucleons, which you use to then do an experimental reaction and measure that reaction. And I have a picture here showing the control room in our lab, which is what you use to actually produce a nuclear physics beam. And the great part about Florida State is you get to turn every knob that you see here and learn how the beams are produced and actually produce them yourselves as a grad student. And then, as I said, at the end of the experiment, at the other end of the experiment, you have particle detectors and targets and all these kind of things that make the reactions happen. And you get to also completely set up your own particle detectors and all the electronics that go along with that. And it's a great learning experience, a great learning environment here at the lab at Florida State. So a little bit about what I do is I have two main areas of research that I've worked on in my time at Florida State. One is nuclear structure and the other one is nuclear astrophysics. So first I'm going to talk to you a little bit about the nuclear structure work I've done. And basically what I've done is the experiments I've run, one of them is called a thick target inverse kinematics experiment. And what that means is the thick target is because we have a helium gas target of approximately 40 centimeters. And it's inverse kinematics because we have a heavy beam instead of a heavy target. That just means that the beam is heavier than the target in this case. I have a schematic here that shows a basic setup of our lab where you have a source that produces an ion. It's then accelerated in the tandem accelerator or the LINAC, or both, either one. And then you have chambers at the end of the experiment that you shoot the beam into with a target, and you measure the reaction products from that in that chamber. And here you can see the little red balls are actually helium gas in my case, and that helium gas is detected in a particle detector. And after going through tens of thousands of dollars worth of electronics, you get something that looks like this, which is an example spectra from our experiment. And what's shown here is just a plot of energy versus probability, where you have for different energy alpha particles, you get a different probability of seeing those, and that's why you see the bump structure, the picture that looks like a mountain range here, is just because of the different probability of seeing an alpha particle. We also do nuclear structure of exotic nuclei, and this is done using the Resolute beamline at the FSU facility. This is actually a fairly new beamline. It started production, I think, maybe 6 years ago, and it just finished last year. And here's a picture of it that you can see where it's very tight because it's a lot of things have to go into a very small space, but it's very effective as well. And also shown here is a sample spectra from our Resolute experiment where we found a peak in the spectra for both elastic and inelastic scattering of beryllium-7 on protons. And so that was a nice find. We're still working on the analysis of this data. Also, like I said, I worked some on nuclear astrophysics. And what I've done with nuclear astrophysics is to measure how quickly reactions are happening within stars. And this is important because astrophysicists need to know these reaction rates so that they can try and model how a star is going to change throughout time. And that's where nuclear physicists come into astrophysics, is that we can measure how quickly the reactions are going to occur. And I actually did 2 of these measurements at Florida State University. And I just want to close in saying that if you are looking at doing physics as a student, Florida State is a great place to come and learn either as an undergraduate or a graduate, because you have a great opportunity to work, get hands-on experience with the nuclear physics group. Thank you.